Good morning, ladies and gentlemen. We are going to start a new chapter today. Woohoo! We've been on the same chapter for a while. So we're going to start 5.1. We're going to talk about properties of exponents and then scientific notation. Our objectives for the day are we are going to remember our properties of exponents. We're going to use those properties to simplify expressions. Then we're going to evaluate some expressions. And then we're going to apply the properties to scientific notation. Alrighty, seem to be having issues getting focused this morning. Alright, so let's just first start right in with our properties. And with our properties, I'm going to do a little example of each, okay, just to get us going on the right track. Alright. See one more time if I can get us focused. There we go. Seems to be as good as we're going to get this morning. First property, if I have a to the m and I multiply that by a to the n, notice that the bases are the same. So these two bases are the same. Multiplied together, then I would do a to the m plus n. All right, so that's our first property. If I do an example of that, if I had 5 to the second times 5 to the third, the bases are the same, so this would be 5 to the 2 plus 3, this is 5 to the fifth, and then if I actually do that math, I would get 3125. Okay, so you always want to simplify your expressions. The next property would be if I have a power raised to a power. Okay, so if that is the case, now that I have a power raised to a power, I multiply. So this would be a to the m times n. So then if I do an example, if I have 3 to the third raised to the second, then that's going to be 3 to the 3 times 2, which is 3 to the 6, and that's going to be 729. All right, so then let's say I have a times b, and that's raised to the n. I could rewrite that as a to the m times b to the m, because that power gets applied to everything on the inside of the parentheses. So let's say I had 2 times 3 raised to the fourth, then that would be 2 to the fourth times 3 to the fourth, alrighty, and then I would get 16 times 81, and that would simplify to be 1296. I would have gotten the same answer if I had done 6 raised to the fourth, which is also possible, but sometimes when I have variables inside, it's just easier to do the math by distributing the exponent. All right. The next property would be if I have a to the negative m. And if you'll remember, I can't leave a negative exponent. All that a negative exponent does is move that expression to its opposite location. So if it started in the numerator, it would end up in the denominator. So you may never leave negative exponents in your answer. You always have to simplify it. All right. So let's say I had 7 to the negative 2. I'm kind of going downhill on my paper, sorry. Then this would be 1 over 7 to the second, and that would be 1 over 49, because 7 squared is 49. All right, our next property would be a to the 0. Anything raised to the 0 power is 1. It's very nice. So if I had a negative 89, and I raise that to the 0 power, that's just 1. So we like having the 0 power. It makes our lives easier. The next property would be if I have a to the m, and I divide that by a to the n, notice again that the bases are the same, then I would get a to the m minus n. So let's say I had 6 to the 4 divided by 6 to the third. It is important that the bases are the same. This would be 6 to the 4 minus 3, so this would be 6 to the 1, which is just 6. And then my last property, if I have a divided by b in parentheses raised to the m, Again, that m gets applied to everything on the inside, so this would be a to the m over b to the m. All right, and in my last example, if I have 4 over 7 quantity squared, that means that this would become 4 squared over 7 squared, so this would be 16 over 49, and then that would be my answer. All right, so the next thing that we're going to do is just quite a few examples using our properties, and then we will move into scientific notation. So I'm just going to do a series of examples for you, kind of illustrating different applications of our properties. All right, and all of these basically are going to say simplify. All right, so that's our generic direction. So my first problem is going to be a -4 times 2 to the 5th, and I'm going to raise that to the 2nd. Okay, notice that everything's inside the parentheses. So I'm going to distribute that 2. So this is a -4 raised to the 2nd times 2 to the 5th raised to the 2nd. A -4 squared is going to be 16. And then if I have a power raised to a power, I multiply. So it would be times 2 to the 10. And then if I do that math in my calculator, and let's talk about calculator work. If I want to raise 2 to the 10th power, I would do 2 and then caret and then 10. And that raises 2 to the 10th power. My answer then would be 163.84. Alrighty, so that would be our first example. Nice and easy. All right, next example. Let's say I have 11 to the 5th divided by 11 to the 8th, and I'm going to raise that to the -1. There's a couple of different ways you can do this, but I'm going to manage the power to a power first. So there are other ways you can do this, but that's going to be kind of how I approach this problem. So this would be 11 to the -5 divided by 11 to the -8. Because both exponents are negative, the numbers switch spots. So this is going to be 11 to the 8 over 11 to the 5, because the negative exponents move both numbers to their opposite locations. Then I can do my quotient property, and I'm going to do 8 minus 5. I'm going to get 11 to the 3rd, and that's going to give me 1,331. All right. Okay, our next example. So just lots of little examples. If I have 2 divided by 9, and I raise that to the 3rd, that's the same thing. It seems like it's awfully small. Let's see if I can make it a little bit bigger. All right, that would be the same thing as 2 to the 3rd divided by 9 to the 3rd, which is going to be 8 divided by 729. And that would be okay to leave it like that. All right, sorry we're having so many issues with focusing this morning. It just seems to be quite entertaining. All right, next example. Let's say I have b to the -4, that's a b, not a 6, times b to the 6 times b to the 7. Because the bases are all the same, then I just add the exponents at the top. So -4 plus 6 plus 7. So 6 minus 4 is 2 plus 7. So this would be b to the 9. Those are kind of yucky looking numbers. All right, next example. Let's say I have 16m to the 4th n to the -5th divided by 2n to the -5. Alrighty. First thing to notice is I have an n to the -5 in the top and an n to the -5 in the bottom, and because they're multiplied, those two terms actually cancel. Alright. And then I can manage my numbers. So I'm going to manage the 16 divided by 2 and then the m to the 4th. So this is going to be 8m to the 4. So that one was kind of polite. All right, next example. Lots of different examples this morning. If I have 8 to the -3rd times y to the 3rd divided by x to the 5th, y to the 6th, and I'm going to raise the numerator to the second power. I think it's a good idea to manage this part first, and if you remember your laws of PEMDAS, P-E-M-D-A-S, which says parentheses, exponents, multiply, divide, add, and subtract, I have to manage the parentheses and the exponent first. Sorry, that's a lot of words to say. So first I'm going to manage the power to a power, so this is going to be x to the negative 6, because 3 times 2 is a negative 6, and then y to the 3 times 2 is the positive 6, over x to the 5, y to the 6. Well, notice again, I have a y to the 6 and a y to the 6, so that cancels. And then I'm going to have x to the negative 6 minus 5, which is x to the negative 11. Can't leave a negative exponent, so I'm going to rewrite this as 1 over x to the 11. So that was pretty nice. All right, here's our last example in this particular set. I'm going to have 7y squared z to the 5th, and then I'm going to have y to the negative 4 z to the negative 1. Alrighty, so I'm going to manage across, and then when I'm done, I'll manage any negative exponents. So there's nothing for the number to get multiplied by. My y is going to be 2 minus 4. My z is going to be 5 minus 1. That's going to simplify to be 7y to the negative 2. Z, 5 minus 1 is 4. The negative goes to the bottom because I can't leave negative exponents. So in the top, I'm going to have 7z to the 4th, and in the bottom, I'm going to have y squared. And that would be your final answer. All right, so now let's go back and talk about scientific notation. And the reason that we talk about scientific notation in this particular section is because it involves exponents. All right, so scientific notation means that I'm going to have a number times 10 to the n. N has to be an integer, okay, which just means it's not a fraction, not a decimal. And the c has to be greater than or equal to 1, but less than 10. All right. If my n is positive, that means I add that number of zeros. So it means I'm going to basically move my decimal place to the right. So I'm going to do move decimal to the right. And then if n is negative, that means that I'm going to move my decimal to the left. Okay, and I know that you manage scientific notation a lot in your science classes, so I'm just kind of a quick little review about that information. All right, so a couple of examples about our scientific notation. If I have 3.0 times 10 to the 3rd, the 3 is positive, so that means that I move my decimal place 3 places to the right. So if I started with my decimal place here, right after the 3, wow, my focus is unhappy. Alrighty, come on, you can do it. Oh, sad day. Just is really not happy. It must not have had enough coffee this morning. All right, we'll see if I can write a little bit more and maybe it'll get better. So I'm going to take my decimal place and move it 1, 2, 3 decimal places to the right. Wow, isn't that funny? I've never had quite so many entertaining issues with my focusing. Well, fine. See if we can make it happier now. Let's try that. Huh, not so much. All right. We'll get there. So sorry that it's so fuzzy. All right, so let's say I had 3.0 times 10 to the negative 3. Then if I manage my scientific, oh look, it's miraculously better. Manage my scientific notation. My decimal place started right here. Now I'm going to move it 1, 2, 3, and my decimal place would be right there. And that's about all there is to scientific notation. So then, of course, we want to make it much more fun. So the thing to remember about managing scientific notation is that the numbers play together, and the 10 to the whatever is going to play together. All right, so our numbers are going to work together, and our numbers that are raised to an exponent are going to play together. So for example, let's say you were told, just like all our other ones actually, to simplify. And I have 6 times 10 to the 4th, and that is divided by 3 times 10 to the 7. So if I want to manage this, the numbers are going to play together, and the 10 to the power is going to play together. So I would do 6 divided by 3, and then here's my x. It doesn't mean that's an x, that means multiply. And then I would do 10 to the 4th divided by 10 to the 7. So 6 divided by 3 is 2 times, and then here's my 10 to the 4 minus 7. So this is going to be 2 times 10 to the negative 3. This is actually the only time that you can leave a negative exponent as part of your answer, because this tells you, sorry, bad grammar, which direction you're going to move your decimal place. Since it's negative, I would start with my decimal place here, and I would move it 1, 2, 3 decimal places, and so that would be my number just in decimal form. All right, so now what I'm going to do is I'm going to do another example. So I'm going to do 1.1 times 10 to the negative 3, and I'm going to divide it by 5.5 times 10 to the negative 8. Again, the numbers play together, and the 10 raised to a power plays together. All right. So when I do this math, I'm going to get 1.1 divided by the 5.5, and then times 10 to the negative 3 minus a minus 8. Because remember, the rules of exponents say if the bases are the same and I have division, I subtract. So then if I simplify this, I'm going to get 1 over 5, and then I'm going to have times 10 to the negative 3 plus 8. And then if I keep simplifying, okay, 1 divided by 5 is 0.2, and then I'll manage this in a minute, and then I have times 10, 8 minus 3 is 5. Scientific notation says, if you'll go back and look at the rules, that this has to be a whole number. So I'm going to move the decimal place 1 place to the right here, which means this one would move 1 place back in the opposite direction. So this is going to be 2 times 10 to the 4th. All right? Let me say that again. So because I moved this 1 place to the right, then I would move this one 1 place to the left, which means I subtract 1. So I have 2.0 times 10 to the 4th. And we like to write our scientific notation and include that 0.0 just to make sure that nobody misunderstands what I'm trying to communicate. So this would be my final answer. All right, one more example. Actually, I lied, 2 more examples. So the next one with our scientific notation would be 1.2 times 10 to the negative 3, and I'm going to multiply that by 6.7 times 10 to the negative 7. All right, numbers play together, 10 to the powers play together, so this is going to be 1.2 times 6.7 times 10 to the negative 3 minus 7. So this is going to turn out to be 8.04 times 10 to the negative 10. And that would be my final answer. I would not ask you to write this with 10 decimal place changes. All right, one more example with our scientific notation. So let's say I have 6.0 times 10 to the 8, and I'm going to multiply that by 1.5 times 10 to the negative 4, and I'm going to divide all of that by 2.0 times 10 to the 7. Same rules apply, numbers play together, and 10s to the power play together. So I'm going to have a 6.0 times 1.5 divided by 2.0 times 10 to the 8 minus 4, and then I'm going to subtract the 7. These are the two on the top. They're added together. I'm just adding a negative, and then the 7 is in the denominator, so I subtract it. When I do this math in my calculator, I end up with 4.5, and when I simplify this, I end up with 10 to the negative 3. And that would be my final answer. Alrighty, so now let's get your problems for the day. There weren't very many, so it's a nice polite start to the chapter. Alright, so here are your problems. Nice to start a new chapter and do something different for a little while. Number 1 says evaluate. And I'm going to have 3 divided by 5, raised to the 4th. Okay, and you'll want to go ahead and simplify that fraction. Leave this one in fraction form. Don't put it in decimal. Okay? Number 2, I want to evaluate. And I'm going to evaluate 2 to the 4th, and I'm going to raise that to the 2nd. All right? And again, you'll give me an answer for that. Number 3, I want you to simplify. And you're going to have 7.2 times 10 to the 9. And then it's going to be multiplied by 9.4 times 10 to the 8. All right. Number 4 is also going to say simplify. We're doing lots of simplifying in this particular section. All right, so your first one, A, is going to be P to the 3rd, Q to the 2nd, and I'm going to raise that to a negative 1. Your next problem would be x to the negative 1, y to the 2nd, divided by x to the 2nd, y to the negative 1. And again, remember you're simplifying all of these. I have 2 more. So C is going to be 4x to the 4, y to the 5th, divided by 24x to the 4, y to the negative 5. And then your last problem is going to be y to the 11 over 4z to the 3rd times 8z to the 7 divided by y to the 7. Okay? You can't see number 1, but these are your problems for the day. Good luck, and I will see you tomorrow.